Hello everybody, and welcome to Math 215, Discrete, what do we call it? Yeah, just Discrete Math. I know things have been rough, and we've been trying to find a good time to have class, and everything is up in the air. With all that said, and I am sorry that is happening, we're still working on trying to figure it out. I thought it's not fair for everybody to just be put on hold while we're waiting, so we're going to start doing the math with some videos, and then as we figure things out, we'll see what happens from there. So today we're going to start with something called truth tables. There's some vocabulary I want to go through, and then we'll just start in and see what happens. If you're following along in the book, I'm going to start on chapter 1. Truth tables is the logic chapter, and this is page 19 in your book. So the first vocabulary word is a statement or statements. What is a statement? This is actually not a very detailed or in-depth kind of definition. This is just a simple word. We use the word statement all the time. I just want to point out that in this case, when we're talking about logic, a statement has to be either true or false. So, the sky is blue is a statement. The 49ers are the best football team ever? Not a statement. It's not a statement because it's an opinion, and an opinion cannot be proven true or false. So we need to make sure that whatever statement we make is either true or false. And it doesn't matter whether it's true or false, and that it's one of those things that could change. Right now, the sky is actually sort of gray. Once we have statements, we can break it down into simple statements and compound statements. These words mean the exact same thing they did when you learned them in English class in probably 7th grade. A simple statement is just one idea. The sky is blue. A compound statement combines multiple simple statements. Let's see here. If the sky is blue is a simple statement, then the sky is blue and the grass is green makes it a compound statement. We combined the sky being blue with the grass being green. Those are two simple statements which then become a compound statement when put together. You'll notice that a compound statement was put together with another word. That word that I used was and. There are other ways we can do it. For instance, we can use the word or. It is raining or it is snowing. Two separate ideas that are put together in one compound sentence. Now, in logic, we actually use letters to represent ideas. So instead of writing out the entire sentence every time, we will use some symbols and some letters, some symbols and some letters, and together we will put those into really meaningful things that don't take up a lot of space. Generally speaking, P and Q are statements. They're simple statements usually. So P will be, for instance, the sky is blue. Then Q represents the grass is green. this is where I point out I'm just making up these examples. So we have some symbols which are really important and you'll get used to seeing very quickly, I promise you. This thing that looks like a V means or. We use that as P or Q. That combines two simple statements into a compound one. That says the sky is blue or the grass is green. We have another symbol which is like an upside down V, which means and. And if we say P and Q, I'm saying the sky is blue and the grass is green. We have another symbol which is useful and not really compound, but we use it all the time. And this is, how do we say something is negative? How do we get the opposite? And your book uses this symbol. So we can say not P. It literally takes the opposite. So if P means the sky is blue, then not P is the sky is not blue. Notice everything I'm telling you can either be true or false. If the sky is blue, then to say the sky is not blue makes it false, right? So when we take the negative of it, we're actually changing whether it's true or not. We can represent all of this stuff in something called truth tables. And that's really what this section's about. Truth tables are a way to draw the logic Sorry, I ran out of space there. That's true and false. And I just want to point out, when I say that they're a way to draw it, it actually gives you every possible combination of true and false. Here's what a truth table looks like. We've got a table, right? And we start with a P and a Q. And P and Q is always whatever statement we're starting with, and honestly, it doesn't matter what we call it. We can think of P and Q as the sky being blue and the grass being green, or we can think of it as something completely different. It doesn't matter, because once we break it down to the symbols, we can do the truth table and not even know what P and Q stand for. Your table is always going to start the same way, and like I said, this is every possible combination of true and false. Notice here we have P is true, Q is true. Then the next one down we have P is true, Q is false. One after that we have P being false, Q being true, and then at the very bottom we have both are false. That means with these 4 different lines we've got every possible combination of P and Q with the true and the false. If we get more statements, this gets more complicated, but for now let's stick with this. Now, how do we do a truth table for something else? Well, if we want a compound statement, let's start with the not. Not is easy enough. We say not P, and we just create a column here that says not P, and so we look at P, and not means the opposite, so we just take the opposite of everything in P. So if P is true, not P is false. And if P is false, then not P is true. Literally the opposite. We can do the same thing with Q. The rules don't change depending on what letter it is. Then we get more interesting, like what do the words and or mean? So what does it mean for a statement to be true if it's an or statement? Or means either. It could be, if at least one is true, then the or statement is true. If the sky is blue or the grass is green, if either one of those is true, then my statement is true. So we see we have P here and Q here, and in between we have just some symbol. So we go back to our original P and Q. P is true, Q is true if both the sky is green, if the sky is blue and the grass is green, then clearly the or statement is still true. They are both true. The next line down we have the sky is blue, but the grass is not green. Well, that's okay as long as one of them is true. The next one down we have the sky is not blue, but the grass is still green. So again, we have it true. On the very last one, because P is false and Q is false, the sky is not blue, the grass is not green. I don't know what colors they are, but my statement is wrong. I lied. It's not true. So this is how the truth table works. We refer to P and Q, figure out how they relate to each other, and put it in our new column with the compound statement. What if we put an and in there? P and Q. In order for an and statement to be true, both need to be true. If I say the sky is blue and the grass is green, both of those things need to be true or I've lied to you. So on the first one here, we go back to P and Q. The sky is blue, the grass is green, both of those are true. I'm telling the truth. I've made a true compound statement. Now, you'll notice every other option here, somebody lied. On row 2, we've got the sky is blue, the grass is not green. My and statement is not true. The third row, we've got the sky is not blue, grass is green, but I said and. They both have to be true. And on the bottom, I don't know what color they are, but sky is not blue, grass is not green. I have lied a lot, and a lie is still a lie, so that is false. Okay, let me introduce you to some other things that we actually use in English, but are a little harder to understand in math. So I just want to make sure we're on the same page here. We have something called the conditional. The conditional statement says, if you do something, then I will do something. That's an if-then statement. We read it, if P, then Q. And the symbol here is an arrow. Okay, there's another statement that's similar, but I'm going to point out the difference here. We have something called a biconditional. A biconditional is actually a two-sided arrow. It says P if and only if Q. And that looks like this. Okay, so a little bit of vocabulary there. How does it work? Well, I like to think of these two statements as promises. Both the conditional and biconditional are promises. The thing is, and this is how you can tell the difference, one is a promise I like to think of from the kid's perspective. It's what the kids want you to mean. And the other is a promise from the adult's perspective. It's what you think you mean when you say it. So for this case, we're going to let P be pass the test. And we're going to let Q be ice cream. This is my favorite example, so the conditional statement, if P then Q, says if you pass the test, then I'll buy you ice cream. The biconditional actually says what you think I just said in the conditional. It says well, let's do this backwards here. I'm going to put it in a different order just to put the words so they make sense. I will buy you ice cream if and only if you pass the test. Okay, so how are those two different? The truth tables are different because one of them has a loophole. You think you've said something, but you really didn't. Again, these truth tables always start the same way. But here, it's only false if I've broken a promise. Even if it doesn't make sense, it's only false if I've broken a promise. And remember I said the conditional is from the kid's perspective. So for the first row, you passed the test, I buy you ice cream, have I broken a promise? The answer is no, I did exactly what I said I would do. Not a broken promise, not a false statement. The second one, you passed the test, which is what I told you needed to do, and I still refuse to buy you ice cream, that's a problem. I just broke a promise. Now, here's where it gets complicated. If you fail the test and I buy you ice cream anyway, have I broken a promise? If you're a parent, you're probably saying yes, but that's not right. Like I said, this is from a kid's perspective. You want to find the loophole, and here the loophole is, you said you'd buy me ice cream if I did pass the test. You didn't say anything about what would happen if I didn't pass the test. So this is actually not a broken promise because you didn't mention failing the test. You only said something about passing the test. The same with the bottom. You failed the test, I didn't buy you ice cream, nobody can claim that's a broken promise. So here, the only thing we have here that's a problem is the broken promise and you've broken the promise when, or I've broken the promise when you pass the test and I refuse to meet my end of the bargain, which is buying you ice cream. So that's the broken promise right there. What about the biconditional? I know it's probably confusing. I'm putting P if and only if Q, and sometimes I'm putting Q if and only if P. The thing is, in this case, they're the same thing because the rule is they go together. This says, I will only buy you ice cream if you pass the test. So it says, if you fail the test, you will not get ice cream. If you pass the test, you will get ice cream. This closes that loophole you didn't know you were leaving. So, you pass the test, I buy you ice cream, I have not broken any promises. The next one, you pass the test and I do not buy you ice cream, that is clearly a broken promise. Here's the closed loophole. If you fail the test and I give you ice cream anyway, I've actually messed up. I broke a promise because my promise now says that you don't get ice cream if you don't pass the test. So this is the loophole. And then at the bottom, notice, you fail the test, I refuse to give you ice cream. That is exactly what I meant to say. So the biconditional says that P and Q go together. Whatever P is, Q is the same thing. It says that they match. It's only true when P and Q match. Okay, I'm going to pause there and I'm going to assign homework. It's number 1 on page 23. There are a few parts to that. Some of them are in the back of the book, but just start by trying to figure out how to construct some truth tables. We'll work on it in class. We'll go over some more stuff later, but here's a good place to start.
Made with Doodlecast Pro.